Okay, today is June 15th, 2011. We're taking up Chapter 7 test. Okay? So the first question on the Chapter 7 test dealt with similar triangles. It asks you to find the lengths of X and Y. There's triangle ABC, which is the larger of the two. And then there's triangle A1, B, C1, which is the smaller of the two. Okay? Now, first off, what we're going to do is we're going to solve for X, and then I'm going to solve for Y. X is the easier of the two. Now, remember, there is a common ratio here. We know that the smaller triangle, 14, okay? And we can find out what our K is. So what we're going to do is we know that 14 times some number, we'll call it our K, is going to equal 22. So K is equal to 22 divided by 14. That's when I bring 14 to the other side of the equation. I have to divide by it. And finally, 22 divided by 14, we divide 22 divided by 14, we get 1.57 rounded to. Okay, so our K factor is 1.57. So what that means is to get from the smaller triangle to the larger triangle, I need to multiply by 1.57. Now this comes in handy because I already have the distance of this side of the small triangle. I know that it's 30. So in order to find the distance of this side of the large triangle, I'm going to take the 30 and multiply it by our... Okay, so I'm going to take that 30 and I'm going to multiply it by our K factor to find out the distance of line segment AB, that side of that triangle. So 30 multiplied by our 1.57 is going to give us 1.57 times 30 equals 47.1. So it says that this side of the triangle is equal to 47. I thought decimal shouldn't be that. 47.1. So that means from here to here is 47.1, but that's not how long X is. X is the distance from here to here. I need to take that value and subtract the distance of the smaller triangle in order to find out what X is. So I take my 47.1 and subtract 30, and it was 17.1. So X is equal to 17.1 units. Okay, so the other side of the triangle is a little trickier. It's given us the distance from C to C, and it's asking us to solve from A to C1 here, okay? So what I do know is I do know my scale factor, and I'm going to make two equations. I know that just side Y right here times that scale factor, so side Y times our scale factor is going to equal side Y plus 15. So this side Y, and I add this side 15, that would be the entire distance here. So Y times 1.57 is equal to Y plus 15. What I'm going to do is I'm going to multiply Y times this. We get Y plus 15. I'm going to move this Y to the other side of the equation. Now what's technically in front of that Y? A 1. So when it goes to the other side, it's going to be a negative 1. So I have 1.57Y, subtracting 1Y equals 15. When I subtract 1.57Y minus 1Y, I get 0.57Y equals 15. And we need to isolate our Y. So I'm going to bring it to the other side, which means I need to divide by 0.57. Y is equal to 15 divided by 0.57 equals 26.31. 26.31. Okay? So we've now solved for our side y. Side y was equal to 26.31. Okay, question 2a asks us for tan 34. It is a very straightforward question. All you had to do was push tan 34 in your calculator. 0.67. Okay? That's it. That's all I wanted. B asks us for cos A, which is equal to 8 divided by 13. You need to solve for A. So first we can do our 8 divided by 13. That's not 13. Okay? So we would get cos A is equal to 0.615384, blah, blah, blah. It goes on forever. You need to move cos to the other side of the equation to solve for A. So when cos goes to the other side, it's inverted to the answer from above. So we're going to do second function cos of the answer. And you would have got 52. So A was equal to 52 degrees. Okay, question 3 says solve for side A and B. Okay? They also give us this measurement, which is 32 degrees. So if we're going to solve for side A and B, we need to use the information we have. From A to B, this line is called hypotenuse. That's right. So this is our H. So this is our hypotenuse, and we have this angle here. We could use two different formulas to solve. First, we're going to solve for side A. So side A, we would have the adjacent, we're looking for the adjacent, and we have the hypotenuse. In that case, we're going to be using cosine. So cosine 32 is equal to adjacent, which is our A we're trying to find, divided by the hypotenuse. I need to bring 11 to the other side of the equation, so it's 11 times cos 32 equals side A. Side A is equal to, and we can do this in one step, cos 32 times 11, 9.3. So side A was equal to 9.3. Now we're going to set up side B. Side B, we have the opposite side we're looking for, and we have the measurement of the hypotenuse. I'd be using sine law for that. So sine 32 is equal to the opposite, which is our B, divided by the hypotenuse, which is 11. Exact same idea. Bring the 11 to the other side, multiply by sine 32 equals B. Sine 32 times 11. Side B is 5.8. If you rounded and you put A was approximately 9 or B was approximately 6, I still probably gave you the answer. Okay? Question 4. Question 4 gives us a triangle again. Measurements of this triangle are 4, 5, and 3. Tells you that it's 90 degrees. And it says to solve all angles of the triangle. So we need to solve both of these angles here. We'll call them X and Y. Okay? So it doesn't really matter which one we start at. We can use any of the ratios to solve for these. Remember, I'll write the ratios down. We have which means sine theta is equal to opposite over hypotenuse. which is cosine theta equals adjacent over hypotenuse, and TOA, tan theta equals opposite over adjacent. So I could set up any of these three to solve for the angles. If you guys notice, let's say we go for side X. I have the adjacent, the hypotenuse, and the opposite. I can do any of the formulas to solve. So let's use cosine to start. Cos X is equal to the adjacent side, which is 4, over the hypotenuse, which is 5. Okay? 4 divided by 5 is 0.8. And I got to bring cos to the other side of the equation. So, when I bring it over, I get cos inverted 0.8. We plug that in. Second function, cos 0.8. X is equal to 36.8. And if you round it, X is approximately 37 degrees. So, we know that this angle is 37 degrees. I could use any of the SOHCAHTOA to solve for the opposite angle, or I can use the knowledge I have now. I have two of the angle's measurements, and I know a triangle adds up to 180. So if I subtract the 90 degrees, and then I subtract my other angle, which is 37, I end up with 53. So the other angle Y is 53 degrees. 4. Question 4 asks us to solve the triangle. In other words, they want you to find every side and every angle. The angles are easy. We already have two of them. We know the triangle has to add up to 180. So one of the angles is 90. We subtract. The other one is 60. 30 degrees. So we've already solved all of the angles in the triangle. Now what I need to do is solve for sides. We're going to constantly have to work off of the hypotenuse because it's the only side we have. So what we'll do is we'll use angle 60 degrees to solve. Hypotenuse and adjacent. So if I'm solving for something I need to find the hypotenuse and the adjacent, I'm going to use cosine 60 is equal to the adjacent, which is our A, divided by the hypotenuse. I bring the 8 over and multiply it by cos 60. Cos 60 times 8 equals 4. Yeah, you could have done it in one step. So this side is 4 meters long. And we use the exact same angle, but this time we're looking at an opposite side. So I'd be using sine 60 is equal to opposite over the hypotenuse, which is 8. I bring the 8 over, and we use the same idea, sine 60 times 8, 6.9. So the opposite side is equal to 6.9. Many of you guys rounded to 7. So the sides of the triangle, the question mark is approximately 7 degrees, or 7 meters. Side A was 4 meters. And our missing angle, which would be, oh, they don't give them letters. Our missing angle is 30 degrees. Okay, question 5. A building casts a shadow that is 16 meters long. So let's create this building. Okay, a building casts a shadow, okay? So let's say the shadow goes this way, shadows are on the ground. The shadow is 16 meters long. And it says the angle of elevation to the top of the building is 65 from the end of the shadow. So the angle of elevation, that's a straight line going upwards, is 65 degrees. What's the height of the building? So this is our X. I have this angle here, 65. I have the adjacent and I'm looking for the opposite, which means I'm using tangent. So tangent 65 is equal to the opposite, which is x, divided by the adjacent. We bring the 16 to the other side of the equation. Tan 65 times 16. Our building's height is 34.3 meters long. Okay, question 6. A laser light is placed 16 meters from the base of a wall. So we got some wall, and our laser light is 16 meters away. Hey, exact same measurement. Look at that. Here's our laser. It says the laser shines up the wall to a point that is 7 meters up from the ground. So let's say it goes up like that to the wall. Remember, our wall can be as tall as we like. And it hits the wall at 7 meters above the ground. At what angle of elevation should the light be set at? So we're looking for the angle here. Angle of elevation. We have the opposite and the adjacent side. So again, we're going to be using tangent. The only difference, opposite is 7, adjacent is 16. The only difference is we're trying to find the angle. 7 divided by 16. Tangent x is equal to 0.4375. And when I bring tangent to the other side, I get tangent inverted to that above answer. (23.62), or if you want to round, it's approximately 24 degrees. So our angle of elevation was 24 degrees.